All right, so I'm gonna start first with some updates. So first update is tomorrow we're gonna have our first weekly study group. So those of us who are, second years can help you guys out because we've done your classes already, and some of you have different professors than we've had, so it'll be interesting. Yeah. Like some of you are like, oh, we're like doing decision trees from scratch. I'm like, I've never even done that before. So that'll be interesting to help you guys out if you want it. It will be in the SE study rooms. That's Golisano 1550. It's kind of like that hallway. You've probably been into it. You guys have access now as of this week or last week. And we're going to record all of these and put them onto our new YouTube channel. So if you ever need to review something or ever miss a meeting, we can view it anyway. So for our semester schedule, we had to change one thing around just because we had to work around our guest speaker schedule. So just data cleaning and feature engineering is going to be moved up by a week, and then our guest speaker will be the week after. And hopefully you guys can still attend that. So for today's schedule, we're going to go over like the conceptual principles of data visualization, and then we're going to take you through a Matplotlib and Seaborn tutorial, just like we did with pandas and NumPy. So to start, I'm going to tell you guys about the fundamentals of data visualization. There's a surprising amount of work that's been done on this, and the founder kind of this field was Edward Tufte, and he wrote a lot of textbooks and stuff about like data visualization in the 80s before even like the digital age. And the reason they had to think a lot about this is because they were doing everything by hand. So if you think about, you need to go out and draw this map. Before you start doing that, you probably want to know what you're doing first. And we have the luxury of being able to just generate, plots at will within, sub-seconds. But if you need to actually sit down and draw everything out, you're going to think really hard about how you're representing your data. And so that's where all these foundations come from. So he had the idea of graphical excellence that he wrote about. And so he had like three kind of core tenets to what he said makes any visualization graphically excellent. So he said, well-designed presentation of data of substance, statistics, and design, complex ideas communicated with clarity, precision, and efficiency, and the greatest number of ideas in the shortest amount of time with the least ink. You can tell how dated that is because the least ink in the small space. So he's even talking about drawing it by hand, even though, we don't care. I guess we would say like the least amount of pixels, maybe. I don't know. But I thought we would go through a couple examples of just like really bad visualizations and see what you guys think and what you guys can pick out and like critique. So the first one's a really rough one. So stare at this mess for a while and just, gather some thoughts. What are they even trying to represent here? And, what are they doing poorly and how could they improve? Like, what do you guys think? Yeah. 100. Yeah. I think they were going for like an artistic thing. Like they were trying to make it look like blood, kind of like going down a wall, but they've completely sabotaged the readability, right? So like, what else?
The axes aren't labeled
Yeah.
Years, and I guess that's on the left-hand side, but it's like not labeled.
Yeah, but we could more clearly label these axes because like you can't immediately look at it and know what it's talking about, right? So yeah. Any more thoughts, or we can move on to the next terrible example if you want. Yeah. Yeah, the color here represents nothing. It's just for artistic purpose. Like so here, someone made this in Python, but there's something very clearly wrong with what they're doing. I want to see if you guys can pick it out. Exactly. I think they're misrepresenting their data because look at the scale for Biden versus Trump, because the values should be very similar, right? But one is scaled from 10 to like 12 and the other is scaled from 0 to 14. So I would argue they're misrepresenting their data intentionally because they probably have like a political opinion, right? Okay, and then the last one. Yeah. So what do you guys think is wrong with this? Everything? Yeah. Be more, break it down.
Don't match with
Yeah. Yeah. There's no,
On single chart and like just break it down.
yeah.
So like slices basically.
So there's like the proportionality they're trying to represent is not there at all. Cause like 91 and 5%, it's hard, like they kind of look the same height, right? Yeah. So yeah, obviously this person probably shouldn't graduate high school. I don't know. So yeah, so let's look at this graph and like think of some ways we could improve this. So what information is on the graph? Like what's useful, what's not useful? Like what would you guys change?
It doesn't need to be a bar chart.
That's okay, that's one thing. Maybe the style of chart is off.
Only we can write just project in x-axis and 1, 2, 3,
Yeah.
not repeating project.
Mhm.
Are this project sequentially done?
You don't know.
Then we can just sort it.
And you see, there's a legend there for a single value. Is that like is that like yeah, we can really tell those apart from all the error rates. So like let's like clean it up a little bit. So one, you don't really need the bars across because they're pretty proportional. Two, you don't need a legend, and again, you don't need to keep saying like project 1, 2, 3. You should just label it project and then go across. So we can clean it up a bit. So now it's not so cluttered. We're still representing our data. We should probably label our axes, but this is, you can look at this and have a much clearer understanding of, what's happening. If we want to get really fancy, you can order it, then, label your axes. And then I think this would be a more like human-centered design where it'd be easier to compare because now it's in like a descending order. And it's just like plain and simple right there. We're following all of Tufte's principles. So in summary, like kind of like breaking down what he said was like basically good charts need to tell a story about the data, not like the gun violence one. Don't do that. You want to choose the proper graph format. Like we saw in one graph, maybe that wasn't even the right choice. They should have just done a pie chart instead of like whatever they were trying to do. And then use appropriate scale. Like we saw people were misrepresenting basically their data based off of just scaling their data differently. Like you could say, oh, I was showing the numbers, but it's like, no, you weren't, it wasn't proportional. Let's see, use words, numbers, and drawings together. That's kind of like a general one, but remember it was the 80s, so you just need to tell people this. Make the complexity of the data accessible and avoid content-free decoration. He called that chart junk. So like we saw, all the way back here, I would call most of this chart junk. It doesn't add any information. It's actually taking away from the clarity of what it's trying to tell, and it just makes everything more confusing. So yeah, and I want to add an excerpt from his book because I read it for a class. I took a data viz class, and you go through the class and you're reading this book for the whole semester, and at the end of the book, he says the principle should not be applied rigidly or peevishly in spirit. There are no logical or mathematical certainties. It's basically better to violate any principle than to place graceless or inelegant marks on the paper. So he's like, there are all these like foundational like data visualization principles, but in the end, just make it look good. Like that's how he ends his book. That's his epilogue. It's like, I laid all this out, but you don't have to follow it. Just make sure that it's a readable thing. And I think that's kind of carries over to data viz in general, because it is like a very human-centered, field. You need to make sure that people can perceive, what you're doing clearly. So these are good, metrics to follow, but just make sure that someone else can understand what you're trying to show them. So now that we've gone over the conceptual stuff, we want to go into the actual tutorial, and Tolu will give you a Matplotlib and Seaborn tutorial.
Sweet. So just so you guys know, I suppose you guys already do know, there's some pretty popular libraries in the Python like world. Matplotlib. Both of them are for data visualization, of course. Matplotlib is the one I use most often, and Seaborn is really, I think, a derivative of Matplotlib. There's some really cool things you can do with it. So what are the most commonly used data visualization libraries in Python? Well, that's a fantastic question. You guys are in the right place. We're going to use Matplotlib. As stated last week, once again, I'm always going to post the documentation for these libraries that we use, just because A, it's good to see the website, and B, you're always going to be referring to documentation in case you want to look at how to create a certain type of plot with respect to your data. It should be said that different types of data, I don't know that you can use any given plot for them. For example, if you want to show, say, changes in some numeric quantity over time, you may prefer some plots over other plots, but we'll go through some of those things right now. So first, how do we even invoke and tell Python, hey, we want to use this library? Well, we say import matplotlib.pyplot as PLT. PLT is just how we're communicating to Python. We're saying we want to be able to call from this library every single time, and we don't have to type matplotlib every time. So we just have a little like acronym or like moniker, you could say, right here. We're using NumPy as we did last week, and we're using pandas as we did last week. So like I said, we're going to shift enter, and that's how we start it. So again, we're making some basic plots. So how do we create something like a line graph, for example? It's really simple. You know, Python allows us to create a variable. We have a quick list, and we can just create some quick values. And then we use some of the methods inside Matplotlib. So here we have the plot function. We're just plotting our X and our Y values. We're going to create a title, X versus Y in this case. We can adjust the font size, you know, the Y-axis, the X-axis, for making sure that we name them, whatever we would like in particular. And then plot show, plt.show, just literally just shows us our plot. So obviously this is like a very basic graph. We will increase in complexity as we go through today. But here we're saying, hey, we want to change the size of our figure that we just generated. So as I told you guys last week, and I'm happy to repeat this because repetition breeds understanding and confidence, we want to always be able to see the different parameters inside any of our given methods. How do we do this? We just go anywhere inside the parentheses, and we can do, at least in Mac, I know it to be Shift Tab. So let's Shift Tab, and boom, we see what's known as the signature. These are all the parameters inside any of our given methods. And this is going to be really important, especially in data viz, just because in data visualization, there's like a lot of different parameters. You can tweak and tune a bunch of different things in your graph to make it really customized and really like beautiful or advanced, or give you like a lot of good information. So in this case, these are some of the things we're able to see. Fig size allows us to go from this relatively small graph to a bigger graph. DPI is dots, inch.
If you want to print it, it's how fine detail you.
Yeah. So this is, again, the same iteration of the graph we just did before. It is literally the case that we're just saying, hey, just make it a little bit bigger. So now we're going to do something called a scatter plot. So whenever you guys do something along the lines of like maybe like clustering in your classes, you want to see very clearly the different groupings of different categories of your data. And so you'll probably run into using scatter plots. And so this is a quick way to generate one in Matplotlib. We're saying, hey, this is the figure size we want. We're generating random data points. That's what np_random.random does. And then we're saying, hey, plot a scatter. We have a marker. In this case, we're saying it's O. So basically all the data points are going to be like the letter O, and color is B for blue. And then moving forward, you guys can just see it reads pretty clearly. We have our title, our X and our Y axes. The font sizes are pretty clear, and that's that on that. So now we're going to move to the bar chart.
Semicolon trip.
Oh, yeah. Something super cool is that if you noticed, or I think it's cool, you can use plt.show in order to just show like your data in terms of the graph. But also, if you don't want to have to type that, you can literally just like use a semicolon. Like I learned this like as of 2 p.m. today. Like it was like you can just run the semicolon, and it's a very quick and easy way. And it means that you don't have to write plt.show. I like shortcuts, and I suppose you guys do too. So it's just something to make note of. So here we have a bar chart, very simple. Again, we're creating some of the label, we're creating the height, just some simple values. We're saying again, this is what we want the size to be. And you guys you can make the size, significantly larger. So this is X and Y. We can say, hey, 12 by 12, for example. Now it's a lot larger. We can do, any like iteration, 6 by 4. The point is it's very customizable and like super easy for us to like manipulate. So again, we just generated the name, the X and the Y axes. We can also create a legend. If you guys notice, it's not really here. We can generate one of those, but we just want to have a basic understanding of how to create them. So now, let's say we want to have way more labels. Well, let's create that. We want to say, hey, projected wealth in millions. Okay, the name of our plot is bar chart with labels. We're saying the x-axis is going to be named person. We say plt.x label. That's how we actually invoke writing out the name of the x-axis. And then the y-axis is projected wealth in millions. The font size we've also created. So we want to make sure with every single tick mark, we're able to change the name. We want to customize it to whatever we would like. In this case, it's the names of some of the eBoard members. And projected wealth in millions. Yeah. So here's another instance of a different type of plot we can use. We have a histogram. Generally speaking, we can use this to kind of show like a distribution that we would have. In this case, it kind of looks like Gaussian or like the normal distribution. Here, again, very straightforward. I think it's like not that hard to understand. Here we're saying, hey, I want to generate, random data points using a NumPy method, NumPy method. Here, again, we're just customizing exactly what we would like for our axes, and we're showing it. We're showing the data. So there we go. What if we want to have multiple plots within the same graph now? Because there are times you're going to try to see the growth or the trends of different types of things with respect to the same plot. I guess an example would be, maybe like the growth of a stock or something like that. You want to see how some of them grow, or like exponential growth in some mathematical function. This is a pretty quick and easy way to do it. So we're saying we want to create a range of numbers, start, stop, step. We're saying we want the fig size to be 8 by 6. Here we're going to have, so this I believe is the dashes that we see on the bottom. It's like red dashes. And we labeled it 1 in our legend in the upper left corner. And as you'll see, so this is t, I believe t, this is t squared, and this is t cubed. So BS corresponds to, okay, yeah, the blue square. Green, like asterisk is like the green triangle, as you see. So it's just like literally just like creating just like simple things for us to understand. Again, we named the plot, we named the entire graph, the X, the Y. We created a legend, and of course our handy dandy semicolon, which will just invoke it for us. Sweet. And now, of course, we can change the colors of different classes. So in your data science class, your intro course, you'll probably have some kind of assignment, again, where there's some kind of scatter plot or some kind of clustering. This is a really simple way to kind of see how to like distinguish between the different groupings. And so we have, again, some randomly generated data. We have the fig size. We're telling Python that we would like to have some scatter plots. This is going to be for the first class, which we're notifying in our legend in the upper right corner. And we have the second class as well. Again, we label it. I'm kind of repeating this process just because we want you to understand. You have the customization to just like label whatever you'd like. You can create legends. You can create like different colors within your plot. You can cluster your plots. You can create multiple plots within the same, multiple. You can track different pieces of data in the same graph. And so that's why, this process is kind of me trying to make sure you guys understand this. And there's some other small things you can do, adding parameters and axis restrictions. So we're telling the axis that we want to stop at 20, we want to begin at 0, and we want data all the way in between. And the RO corresponds to the red like dot. So it should be like relatively straightforward to understand. This is the same thing when you want to create multiple plots at the same time. Welcome back. I believe I ended off right here. Okay, so if we don't want to define like all the lines, we don't have to like write all the different arguments. So this is just showing the difference between this output and this output. We're just saying, hey, we want to have the red diamonds. We want to have the same functions like t squared, t cubed, and we want a green line as well. I believe we have a blue line there as well. Just some simple ways to simplify it for us, so we don't have to write, as many lines. Instead, we have only 2 here. And as stated before, we could also use a semicolon. Oh yeah, of course we can. Is this any clearer? Okay, sweet. So it's also true that you can create like multiple plots in the same like segment. They're called subplots. It's a way to show like your data at different snapshots, kind of. So here we have like a basic way to just generate them. This is obviously kind of like messy and like overlapping. So how do we straighten it out? This would be saying, hey, I want to create a subplot. We want 3 rows and 3, we want it like 3 by 3. If we use the type underscore layout method, we can just like make them a lot clearer. So now, one thing to mention is that axes is actually like its own object in Python, which means that we can kind of like iterate through it. And we'll talk about that in a few minutes. But anyway, right now we would like to say, hey, I want to create like a quick little data set. I'm using NumPy to do that for me. I'm saying, give me, start at 0, end at 21, and I want 21 numbers, and it's going to go from 0 to 5. And I'm saying x, this is my x value, my y value is going to be, x squared. So really quickly, I can show you like x, okay, that's not what I want to do. X is all these values, it's 20 values, they're evenly spaced. And then y is just all these values squared. So now I'm just generating some pretty simple basic plots. Once again, the same process. We're going to plot the x and y, label our axes. I'm creating 2 plots right now. I'm just creating a quick little loop to say, hey, for all the axes that we have in this little object, we can create some subplots. Here, we're just generating different subplots based on just changing the color of them. And in this, just generating a simple, like, we're just creating some small axes, and then we're saying, hey, plot this for me. As we see, this gives us a memory and location, which isn't too important as of right now. But if we move to the next step, this is a way to just generate, say, some kind of plot. We want to create some axes, and these are some bells and whistles and different things that you can use in Matplotlib to create like a really cool little like graph. So in particular, I'm saying, hey, the x and the y that I had from earlier, let's use that. The color of the line itself will be blue. We can change the width, we can change the style. It doesn't have to be like dotted. It could just be like a straight like line itself. We can kind of customize that. The marker, I chose to make it like a star in this case. We can change that into like a circle. We can change the size of the marker itself into, make it larger or bigger. As you can see right now, the color inside the circle is like red. We can even customize something as simple as that. We can change the width of this green circle. We can change the color of it altogether. Let's make it red. And alpha, I believe, is transparency. So it's to say, hey, you see how thick, or I guess how dark this line is? We can make it anywhere from 0 to 1. So let's say 0.1. It makes it like this entire graph is now like a little faded. So these are, again, little things within the inbuilt plot function that we have. If you press Shift Tab, you can see how you can change anything to your liking. And again, there's a lot of different things you can customize. So this allows you to just like take full advantage over the graphs and plots you're able to make. And a question you might have to yourself is, hey, Tolu, we created this beautiful Mona Lisa of a graph. How do we save it? Well, you can just use the save figure function, and it can just save it to your desktop in case you want to, I don't know, put in some kind of presentation or like a PDF, in case you have some kind of like poster you want to put it on, or you have any kind of, I guess, report you'd like to save your images to, you can save it this way. So it's a pretty simple way to do that. And again, these are just more ways to create simple plots. For example, like, an x cubed or an x squared graph. So now let's get to, I guess, things that are a little more fun and colorful. This is called a heat map or a correlation matrix. And this shows you how to, I guess, take the correlation coefficient to see how linearly correlated some of your features might be. Of course, they're going to have to be numerical features in this case. Here we're saying we're reading in the same serial data set from last week. We're using Pearson correlation, which is R squared. If it's like 0 to 6, it's like weakly correlated. If it's 6.6 to 0.8, it's strongly correlated. Anything above that, it's like obviously like very correlated. So this is just some of the syntax that we've used to generate this heat map. Okay, I did not want you to tell me that. Okay. This is a box plot, which you probably will use in one of your statistics courses, or we've probably seen in some of your statistics courses. It gives you a good understanding of the mean, the different quantiles, like the 25th percentile, the 50th percentile, 75th percentile, the minimum and a maximum value within a data set. So this is just a simple way to generate one. This is for the Setosa like iris data, so like the sepal length and like the width. You guys maybe have seen this in like a basic machine learning course. And so this is the fig size again. This is us generating a title, and we're just showing some of this information. So now this is us showing different like clusters of data and putting like a little regression in between each of them. Again, this is for the classic iris data set. I don't want to get, I guess, too deep into the details of how, but again, it's posted for you guys if you want to like work through it and see how we're generating this. And of course, if we run this, it'll generate for us. So now that was, I guess, some of the basic plots you can generate in Matplotlib. So now we're almost done. We're actually in Seaborn right now. This is another data visualization library, and it gives us like a way to make beautiful graphs that are like really easy for us to understand, but also have like an aesthetic component because you don't always want to be doing like line plots all the time. So first, I'll import the library. I decided to use something that I think a lot of us will be familiar with, a Pokemon data set. So this is me reading in the data set, df equals pandas. They have a function, it's called read_CSV. Reading it in, and now I'm saying, hey, show me the first 5 rows of the data. So if you guys are familiar, all the Pokemon are numbered. These are the names, the types, the total. So these are like all their stats, like HP, attack, special defense, you know, the generation that they're from. It's a legendary Pokemon. And so these are some simple ways to use Seaborn to visualize some of these data sets or some of these components of the data set. So here we have, you know, I want to see all the HP or the health points. And we're creating like a simple, it tells us, this plot tells us the distribution of the data. In this case, it's kind of like normal. Here I want to see the basic information regarding the attack stats of these random Pokemon. And here I'm saying I want to split it into a certain number of bins. So you can add that argument as well. So I decided to put 25. Notice that if you put like a really large number, it becomes like harder to read and understand. So I try to stick with like lower values. This is a joint plot, which allows us to see 2 different components of this data, so like 2 different columns. Here, I'm just interested in seeing the speed and the attack of different Pokemon. I'm trying to see if there's any kind of like relationship with it. So that's what the joint plot allows us to do. In this case, I decided to take another approach. I was like, hey, I want to see the speed and attack, but I want to see a hex graph. So when it's dark, that means that there's a greater density of like Pokemon in this case that have like that like level of statistics. So like, for example, right here is really dark. That means that there's a lot of Pokemon in this entire data set that have like these values. Here is a regression, just trying to get a relationship between these data points. This is a kernel density estimation plot. And the darker it is, it tells us, you know, more of the Pokemon can be found in this region of this like plot. So it gives us like an understanding of like the most common points in the data and the more like outliers of the data.
So the previous plot showed us the before this one. Yeah, so these black spots are actually representing lot of concentration of data points.
Exactly.
But that is showing the region, right? Like the one which you showed just now.
Well, like a contour event.
Oh, sure, from calculus. Okay, good point. Yeah, that's true to say. Further, these are just some of the columns that we have. And I want to show you guys how to create some violin plots because these are also commonly used in statistics courses. So in this case, there is an issue of overlapping like types. So in this cell, I just decided to show you guys how to rotate it because sometimes in your data sets, you will have this like small issue. So it's just a quick little syntax thing you can do right here. And you can create tick labels, you can rotate it. And here we have all the different types. And this is their distribution of their statistics. This is with respect to their attack. Here's with respect to the special attack. And this, I believe, is the last segment. I decided to use some flight data because I figured a lot of people here are international students anyway. So you guys obviously are dealing with a lot of like airplanes and like there's like a lot of flights are taken. So here's some flight data. This is me turning it into a pivot table because in order to create what I wanted, which was a heat map, the data set actually has to be in a matrix. So I quickly converted it into a matrix using what's known as the pivot underscore table. So I have an index, I made some columns, I made some values, I fed it in, and now I've converted this data set into a more easily readable format, which is a matrix. And now I'm saying, hey, I want to create a heat map. So this is telling me over all the different years, what month of the year has the most flight activity. This is kind of, I guess, hard to read because these colors are so dark. So I decided to make it a little bit more readable through the use of like a rainbow coloring. So this is a color mapping and it's called the spectral colorway. And you can literally just like create a line, the line color, so you can see like each of these segments more clearly. And we're saying, okay, we noticed that in 1960, where 600 is the hotter versions of this heat map, we're saying that the more activity occurs on this side of the mapping. So in the later years, so as time passed, there are more flights. And again, I just changed the color here. And lastly, I did what's known as a cluster map, something called hierarchical clustering, which you guys will probably run into as well. This is just showing me, hey, which years are the most similar in terms of flight activity. So if you look at the x-axis here, it's not in order. And that's because this is telling us in 1956, there was the most flight, 1956 and 1955, they were like very similar in terms of how much activity occurred between them. And so this is saying, in the month of January, in the month of February. And notice that the lighter the color, the more activity there was. So this is telling us in August and in July, there was the most flights, which means maybe in the summer vacations that people had, you could say that people were taking a lot more flights, maybe on vacation or for whatever reason. So there's a lot more things that are available in Seaborn and Matplotlib. But these are some of the basic plots I guess I wanted to show you guys for today. Again, we have the documentation. Yeah, there's a gallery in, thank you. There's a gallery in Seaborn. Wait, how do I access it? Right, yeah. So these are like all the various different types of plots that you can generate with Seaborn. Each of them have their own use case and their own reasoning as to when they when you'd like to use them. And so you guys can kind of check this out if you would like. And there's more things. There's like, this is getting into the details of a heat map, when and where to use it, how to interpret it. You can put the correlation coefficient inside these grids, so it's easier to understand. There's a bunch of different coloring patterns. And so these are some simple things you guys can check out. And so that would just conclude today. You guys don't have any more questions, then we can just leave it there. So I'll stop it there.